Hello. Um, Today we're covering the Notary V2 Introduction Status Report. So we've been working on a second version of Notary for a while, and there's an advanced talk later on going through some of the detailed work, but this is really introducing where we are and what's going on. This is a joint thing with me and Omar from Amazon. I'm a Notary maintainer. I work for Docker. I'm on the CNCF TSC, and I work a lot of time with Security, and I'm really interested in the whole security space across cloud native. And Omar's product manager at Amazon ECR, so he's very much involved in the registry space, one of the largest registry operators. So what is Notary? If you're not familiar with Notary, it's a CNCF project. It provides provenance and supply chain security for container images. Basically, in the sort of simplest sense, allows you to sign a container image to say, I made this. The simplest use case is really just signing, my container in, say, when I'm building it on my laptop, and then making sure that when I pull the same version number from my registry, I'm going to get exactly the same container back. That some attacker hasn't maliciously come and stuck a different container in there, or even one of my coworkers. Or if I sign it, I want to know it was my container. Notary is based on the update framework, or TUF, which is also a CNCF project, and it uses TUF as part of the security model for it. And it generally, Notary provides kind of fairly raw tools, and it provides the server-side piece. It's often embedded in more opinionated tooling. So Docker Content Trust was something we built at Docker that made it kind of easy-to-use workflows for signing. And CNAB is doing something similar using Notary as well. So it's it's the server implementation, and it's a set of libraries and tooling you can use directly, but ideally it's got a nicer wrapped interface in something else. In the enterprise, container signing is really about having easy integration to supply chain. We're going to talk about supply chain in a minute. Validating, storing, and deploying the images you want. Setting up policies around signatures to make sure that things that are run in production are signed. Making sure that we have freshness and immutability and so on, which are some of the guarantees that TUF helps give you with Notary, to make sure that you are actually getting the latest version of an image. And this is part of your governance. You've got central governance and compliance. You've got to answer to auditors about your governance, and you've got to manage and audit the history of the artifacts that went into production and know that they were exactly what you thought they were. Because the last thing we want to do is have things go into production that are not what we thought they were. Automated deployments are obviously they're a foundation of what we do in cloud native, and continuous deployment is one of the key pieces of cloud native workflows, but they do provide new attack vectors. One thing that attackers have noticed recently is that if you protect your production infrastructure, then maybe it becomes easier to attack the deployment infrastructure. And there's been a lot of interesting cases, which we'll look at in a second. There are so many places you can attack in the deployment workflow that can be weak. This is a great article from Gartner from 2018 on container security, covering threat vectors in an automated deployment process. And you can see everywhere there's little red arrows, there are places you can attack. So everywhere from the developer's laptop right at the beginning, through to dependencies and deployment systems and registries and everything really up to production. Some recent examples of supply chain attacks that we've seen, these are kind of high-profile ones, but they're definitely becoming more common. Asus Shadowhammer updater attack was added code before the script, the automated piece of deployment that did the signing. So everything was signed. And it was an interesting one because it was the hack was only activated on 55 specific MAC addresses. So most users didn't notice anything was wrong, but 55 computers in the world were being targeted for being attacked, which is kind of interesting. There's also similar with the npm event streamer hack in 2018, where this is where an attacker helpfully offered to maintain an unmaintained open source project. Seemed a nice thing to do, and inserted a backdoor targeted it specifically at developers of a particular application again. So again, most users didn't notice, they didn't alert anyone because nothing weird happened, but these developers were being targeted. And then NotPetya in 2017, again, shipped via an update to a tax management program that was widely used in much of Europe. And then from there, it went and attacked other users. Again, the update was signed by an automated process, and because the build server was totally compromised. Damages from that were estimated at $10 billion. So these are very much becoming high-profile attacks of interest, and so this is where we need to start thinking about building these processes into our supply chain. So the Notary V2 process started off around KubeCon San Diego. Amazon and Azure, Microsoft and Docker met up, and I did a presentation about the kind of issues we were seeing at KubeCon. We had a kickoff in Seattle back in the days when we could meet people back in December, and then we've been working on a weekly cadence. Everything's in the CNCF Slack channel and on Open Meeting Notes, and recordings are available on YouTube as usual. So we've been working on it since then. So why do we need version 2? The main issue, there's a whole bunch of issues, but the most important ones really were making it a registry native service. So Notary V1 is a service that runs on the side of your registry, basically has its own separate database from the registry, sits there and runs in parallel. This is an issue for a lot of reasons, one of which is that not every registry runs this. It's not a part of the registry that's native. I will talk about more of the reasons later. Usability, we identified a whole bunch of usability issues, some of which were due to design and some to implementation, and so there's a lot of things that need to be done there. As well as usability and the kind of normal use cases, understandability and debuggability, being able to understand how it works and being able to fix things when things go wrong, which are all really important things that have proved to be not as easy as we'd like. Notary V1 is used, but it's fairly niche. And we'd like this to be, really widespread. We'd like it to be able so that everyone can use it. And obviously, this is a security product, so we want it to be secure and to have clear, understandable security properties that people really get. And there's a whole bunch of things we'll talk about there. So registry native, we really want all the data be stored in the registry, not in a separate database. This turned out to be a really important thing, and it's kind of come up a lot because people are using registries to store more things, not just container images, such as Helm charts and so on. And there's an ecosystem around the registry now in a way that there wasn't so much perhaps when Notary was new. I mean, Notary is from 2015, when it was really in the early days of containers. So then it was kind of easier to have it as a side service, but it requires registry operators to install and manage another service, which not all of them have. So, you can get Notary on Docker Hub and you can get it on Azure, and Harbor supports it. But for example, Amazon does not at the moment, and many other registries don't. So you don't know if you're going to be able to use signatures, which is kind of unhelpful if you want to move things around. The APIs are not designed for moving signatures around easily either. There's no simple push and pull API. You can sign and you can verify, but it's much more difficult to actually just move signing data around. And because people use a lot more registries now for different purposes, like different registries for production and development and things, that's become really important. So we really want it to be that, when you push and pull images between registries, the signatures come with them as well. And we want to validate signatures wherever the content's located. There was some issues around Notary v1 making some assumptions about the registry where the signature was is the same as the registry you pull from, that caused a bunch of issues. People also want to use signing not in a registry. We've had a lot of use cases being brought up where people want to use containers in offline and disconnected environments. This wasn't really much of a use case when we designed Notary v1. It does have some tooling to support that, but it's not ideal. It wasn't really a design requirement at the time. You can kind of make it work, but you have to know what you're doing. If we have a standard mapping between the registry and file system mapping, say for local use, then that's much, or a cached offline registry that you can use or whatever, then that's much easier. So we really want to support those use cases. A lot of people say that they are not always connected to the internet at all times. Usability is something that we really need to work on. So the raw Notary interfaces with the actual kind of plumbing commands that Notary gives you are not that easy to use. After a few kind of years at Docker, we decided that they were not really suitable for end users, and we introduced a set of Docker trust commands to make a more friendly interface. But although that's covers only quite an opinionated workflow on how to use Notary, it doesn't give you all the options that upstream gives you, but it's way easier to use. There's still difficulties even with that kind of simpler interface, but I think it gives us an idea of what kind of interfaces are better. But the other problem was key management. There's a lot of keys with Notary v1. There's a root key for every registry repository. So a normal user might have a lot of different root keys, and an organization might have hundreds of thousands even of root keys. And then there are the other keys as well as the root keys so you end up with a very large number of keys to manage. Keys then expire. Users are not very good at remembering to do things about keys when they expire. Most people, I think, went for long-lived keys. So the expiry time was, its expiry was not something that was people managed very often. So as we learned with TLS, the less often you expire keys, the more annoying they are. And users are really not used to managing that kind of scale of keys. And so we've had a lot of problems with that from a usability point of view. Backups and all those kinds of things. So we really need to improve the key management side of usability as well for your V2. Understandability and debuggability, I think it's definitely the case that most people don't understand the security model that Tough is using, and that's partly our fault, but for not explaining it clearly. But it's also it's partly the interfaces are not that great for actually seeing, and observing what's going on and understanding when failures happen. And this is it's partly a documentation issue and partly an observability issue and partly a design issue and partly an education issue. So there's a lot of work needs to be done to make sure that we have the right explanations on hand for this. I mean, I think even during this process, it's been clear that people have very different expectations of what I've signed this image actually means. And that's kind of, people have an intuition, which isn't always what the system's providing. And that's really difficult to deal with sometimes because intuitions are kind of difficult to change. So we've got a lot of work to do there. And it's, very obvious even in the process that working with people who are familiar with these things, that it's not actually the easiest thing. In terms of usage and adoption, Notary V1 usage is not that high. It's kind of when we were designing the previous project system that came before Notary V1, every image was signed. That wasn't a great... so arguably you could say, oh, everyone used it, it was great. But in practice, it had other issues about every image was signed, but there was no reasonable way of knowing which keys you should trust. So the signing didn't really actually matter. But the usage is just not as high as we would like. We would like everyone to use this rather than it be a niche thing, because we want everyone to benefit from security, understand the benefits of security, and it shouldn't be a burden to use it. It should just be a natural part of the tooling that we all use with containers. Things should be signed and checked and tell you that there's an error. As I said earlier, not every registry supported signing before, so because it was an add-on, we want it to be built in so that really you can guarantee you can use it everywhere, which would just gets rid of some of the barrier for usage, which is just not being available in your environment. Security properties, we want, as I said, the security properties to be understood and understandable and well written, well explained. But we also, I think there's a big feeling that we want to work with the way that people use container images now, rather than tell people that they have to use things differently in order to get security, because that way they'll probably decide to carry on using things the same way because of familiarity. So we don't want to be sitting there telling people their workflows are wrong, although, I mean, there are definitely issues with how the workflows are, and there are things we should probably do over time to make them better, but the goal is not to prescribe a workflow and then say this workflow is secure and other workflows are not secure, because then that gets in the way of adoption. But some of the security properties are different. So, for example, Notary V1, unlike TUF, is trust on first use. And so trust on first use is what successfully has been used by SSH, or relatively successfully, where when you log into a machine, the first time it says, do you want to trust this key? You're supposed to check. And then in future, you know that the key hasn't been changed, so someone hasn't logged into that machine. Obviously, if the first time you log into that machine, someone has already replaced the key, or it's not even the machine you think it is, then you've got a problem. But if it happens later, then it is actually protecting you, and that's kind of useful for that. But in the cloud native world, we have a lot of ephemeral machines, and if you have if you spin up an ephemeral machine and then it tries to check a key with trust on first use, it's always the first use, because if your container only gets spun up once, runs something, and then goes away again, it doesn't have any history of what the keys used to be or anything. So trust on first use is fundamentally problematic in a cloud native environment, and ephemeral machines are really, really important. Ephemeral containers, everything is ephemeral and in the cloud native world. So we really can't rely on that kind of mechanism. And so that's one of the things in Notary V1 that, I think is not giving people the security guarantees that they would think they were getting, because Notary V1 gives you TUF, but it gives you a version of TUF that has a different key management decision, and that's problematic. Actually, Notary technically gives you a choice of key management, but the implementation that almost everyone uses is the trust on first use one. So yeah, you can actually implement different decisions, but I'm not aware of very many people who do. We did some experiments with that at Docker, and so we did some internal work on that, but it's definitely not the normal use case. So the plan, we've been working on requirements and trying to get everyone aligned, and so we're getting towards agreement on these things. Obviously, now at KubeCon, we're going through and talking to everyone about where we are, what we're doing. There's more in the working session. We are working on beginning prototypes as well, which we'll talk about in that session as well. We're looking to have rough code by the end of September, so 2 months really, in order to do demos for KubeCon North America towards the end of November, and then GA for next year. And Microsoft and Amazon and Docker are looking to GA next year, and also other people as well. We're working with a big community of all the people who are running registries, really. So we're hoping to have more than just that. So yeah, go to the working session. Or watch the recording of that for more information. Some of the discussions that are ongoing, again, some of them we're talking about in the working session, and some of the things we've already had kind of discussion on. One of them has been about adding signatures and content addressability. So registries are content addressable stores, and what that means is that everything is defined by the hash of the content you're referring to. So the contents of an image define it uniquely in the storage. So you can be sure that if you can ask for exactly this version of Ubuntu, because once you know the hash of that version of Ubuntu, you always guarantee you'll get the same content hash next time if you pull by hash. But that kind of constrains the design of how registries work. And one of the things is that a lot of users talked about as a requirement was that they wanted to be able to add more signatures to an image after they had basically already tagged it or referred to it by hash. So you want to say, this copy of Ubuntu, say, I want to add a signature saying that it was checked by our compliance department, or that I want to add the signature saying that it went through our validation program and it was added to our registry. And so we want to be able to add these signatures without changing the content. Whereas if the kind of classic model with content addressability would be that you refer to the content with the signatures. And this is kind of the model that registries expect to work with, that if you want to retrieve an object, you have to specify it. So if you want to retrieve the signed object, you'd have to specify the hash of it with the signatures. And then if you added another signature, it would change. So there's a working group around adding an API to registries that can, given an object, retrieve all the signatures attached to it as a separate item. You will still probably be able to, you should be able to still refer to the signatures directly if you want to refer to the signatures directly, but you would also have an additional registry API for retrieving signatures attached to an object. And so there's definitely a lot of interest in this for this kind of workflow. Another thing that I talk about in the other session in more detail is more about ephemeral servers. Ephemeral servers, as I said, are really important, but they do have security implications, and this is something that really hasn't been looked at much before, I think. But one of the guarantees that TAF gives you is about rollback. So it says that if you've downloaded something, no one can come along later and say delete all the new versions and then tell you that the latest version of the package you're looking for is the one from 2 years ago that happened to have a security vulnerability, because you would detect this had been rolled back because you'd seen versions earlier. But an ephemeral server kind of doesn't have any of that state, so it can't see about rollbacks having happened. So we're looking at other mechanisms, and there's more about that in the working session. Another thing we've talked about a lot is what guarantees users are expecting with signing, whether they're, how many guarantees do they want? What's the expectation about what signing means, and those kinds of issues around, which security properties are you getting? Is it guaranteeing? What's it guaranteeing about the software you're downloading? And then we obviously have a lot of, we have a working group on key management. There's obviously discussions around what kind of keys to use, like X509, GPG, or ad hoc signing, where the trust is built into the actual signature protocol and the whole workflow that we'd be designing. And so we'll talk about that more in the other session. So if these interest you, come and join us at the meetings. So thanks very much for coming, and happy to answer questions, and we'll be working on this, and I hope you look forward to better security through better signing coming to a registry for you soon.